work on the sun. I study the sun. This is my job every single day. My PhD was actually about the composition of the solar corona, and we're going to learn what that is. So Gaston starts his life at the core of the sun. He's born there. He's born there through stellar formation. So what happens to the sun? We have a big cloud, and then the cloud comes together. Gravitation pulls it together, but pressure is pushing outwards, and that forms this sphere that will become the sun. And at the core of the sun, for Gaston to be born, we need thermonuclear reaction. This means that we have atoms that come together through this very complicated process of 3 different reactions with different steps. But in the end, what we end up having is from 2 hydrogen atoms, we retrieve helium, a few extra hydrogens, and then a photon. And then it goes into the next area of the sun, which is the radiative zone and the convective zone. These are still inside the sun. And the radiative zone, photons actually knock into other molecules, and they follow this very complicated path, as you can see. So it's like trying to walk through a crowd. If it's a really crowded place, you're bumping into people and having to change directions, sometimes going back, going forwards. And the convective zone is a little bit like a pot of water that is boiling. So we get hot water that is coming up and a cold water that is coming down, and this creates cells. And we can see the impact of these cells in the sun. So here, this is the solar surface. The areas that are bright is where hot material is coming up, and the areas that are dark is where cold material is going down. You can see the movement here. And so then it reaches the surface of the sun, which is called the photosphere. And this is where the medium becomes transparent. So here you can see a photo of the Eiffel Tower where we have clouds and fog, and so we can't really see the top of it. It's not transparent. But on this much nicer day on the right, you can actually see every little detail. And this is what happens. We go from a medium that is opaque to a medium that is transparent. And it actually took Gaston about 100,000 years to leave the sun, and even snails go faster than that. So the sun is actually a big magnet. So here you can see on the left iron fillings around a magnet. I don't know if you've done this experiment before, but you can see the magnetic field lines going from the South Pole to the North Pole. And we have the same thing at the sun. We have a southern magnetic pole and a northern magnetic pole, and the magnetic field lines are coming from one side to the other. But in reality, the details are way more complex. We have small magnetic structures, and here you can see them in ultraviolet light at the side of the sun. You got these coronal loops that go from a northern pole to a southern pole. And if we look at the schematic view of the magnetic field, it becomes way more complex. And I don't know if you see, but these points where we have these big regions, these big bright regions, they are actually on the surface called sunspots, which are dark. And this is one of our first indications of activity in the universe. Galileo saw these spots move throughout the sun. This was actually the sun turning, but also the movement of the spots themselves. And we see that they appear and they disappear. So it's not something constant on the sun. It's a phenomena that happens and then disappears. And so we reach a further up layer of the sun, the chromosphere. And this is very interesting because we go from a hot interior. The interior of the sun is about 10 million degrees. Then we go back down to we go outwards towards the surface. The surface is at 6,000. The chromosphere goes down lower to 10,000. to 1,000, and then we go back up to 1 million again. So you can see this progression with the solar radii here and temperature. So very hot core, cold surface, but then it starts getting hotter again, which is one of the big mysteries about the sun, actually. And so the chromosphere, you can see it's very complex. We have bright regions. Here on the top left, you can see a big prominence that is coming out from the sun, and you see bright regions and darker regions. Prominences, I hope the video will work, are cold material that is escaping the sun. And this is one of the first images that we have. This was taken about 60 years ago. And so you can see the material coming out from the sun. And this material sometimes goes very, very far out. So here on the bottom right corner, you have the sun, and you'll see a prominence escaping the sun. So you have the prominence here that is going to erupt, and then this leaves the sun completely, this big magnetic structure. And this is when we reach the corona, which is the area that I'm most interested about. So this is the solar corona. This is observations in ultraviolet. As you will see, this is very dynamic. We have a lot of different structures. Some ones are dark, some are bright. You saw Mercury pass in front of our camera there. I'll play it again just so that you can see. You'll see Mercury pass by at the top. Yeah, that round thing. So it's very dynamic. The sun is actually moving and changing and doing things all the time. So one of the keys to this is the coronal loops that I already showed. The corona is actually composed of many things. There's not only photons, but there is iron. This is the purple guys are iron. We have sulfur. We have oxygen. We have different kinds of iron. We have iron ionized 11 times, here 7 times. And my job as a scientist is to look at the composition of the corona and see if it changes throughout the sun. This is the sun in different temperatures. As you can see, the structures are slightly different. And then we go into the heliosphere, so the bubble that the sun kind of creates around itself, and that encompasses all of the planets. So we have something called the solar wind. The sun is constantly ejecting material, and you can see this in solar eclipses. So here you have 2 images of solar eclipses, and you can see that the sun looks like it has ponytails, 2 ponytails where material is escaping all the time. And once again, this is another way of material to escape, eruptions, but you can see that it reaches quite far. And these eruptions can actually reach Earth. And so here you see a small eruption. So this is the red part. And then here you have the different planets. So the sun in the middle, Mercury, Venus, Earth, Mars, and then a few, here you have Jupiter on the top. And you can see that this eruption is expanding and going through the entire interplanetary medium. That has consequences. One of them, one of the most beautiful ones, is Aurora Borealis. So these are the northern lights. Here on the left, you see a view of them from Earth. But this also happens in other planets. Here you can see it in Saturn. Here you see the Aurora Borealis around Saturn's south pole. Thank you.